Hi, it's Mr. Benson here on behalf of the Year 9 team with another lesson video, this time on the surface area of rectangular and triangular prisms. Just one little note, I seem to have a slight issue with my audio where it sounds a little bit like I'm at the beach. I'm not. So yeah, hopefully that's not too distracting. Okay, so the important stuff. What are we learning about? Surface area of rectangular and triangular prisms. In the text you'll find this in 12.5. Now the required knowledge and skills. Now firstly we've got to be able to identify prisms and particularly right prisms, which I'll explain later on, and find the surface area of rectangular and triangular prisms. Here are some exercises and some extension as well that you can have a go at. Okay, so what's a right prism? Now, I just wanted to be a little bit more detailed on this one because there are actually prisms which are not right prisms that you might come along to later on. So in the textbook, it really just talks about a prism, and all the ones that we're looking at the moment are right prisms. So a prism is a solid object with a uniform cross-section and flat sides. So we'll talk about what that means a little bit more in a moment. Now when we talk about a right prism, what that means is that when we look at the angle that's formed, so the angle that's formed between the base and the sides, that angle is always in fact a 90-degree angle or a right angle, so we get right prism. So moving on, when we're talking about cross-section, now the cross-section is what you get when you chop something into slices. And so if you slice up a prism, the pieces that you are making all have the same shape in their cross-section. So a triangular prism, you just cut into smaller triangular prisms, and so on. Now we can look at things that are not prisms. So anything that doesn't have parallel sides is going to not be a prism. And if you think about our cone here, if we were to cut through our cone, say at this point here, so we'd end up with a circular top there. Now this circular piece that we've just cut is not the same size as the original base down here. So that's one way of seeing that our cross section is not the same. The same with cutting a sphere or any of these other pyramids as well. You're not going to get a constant cross section, and so they are not prisms. Another thing that isn't a prism but actually has quite a lot in common is a cylinder. So the reason cylinders are not prisms is because they have curved sides rather than, flat sides. But in terms of a lot of the calculations we're going to do, you'll see that they actually behave in much the same way. So even though they are not prisms, the same techniques that we can use for area and volume and that sort of thing are often handy between prisms and cylinders. Okay, so let's have a think about finding the surface area of a prism. So here I've got a triangular prism. Now it is, okay, so it's got a right angle triangle with 3 different side lengths. Not that it matters that it's a right angle triangle or anything like that. It's just that sometimes the way you do your calculations can be simpler if you've got a whole lot of sides that are the same. And then you only need to calculate the area of one side and then multiply it by however many you've got. So when we are doing this, we can think about how we can represent a 3-dimensional object as a net. So this is, imagine that we were building a model of a 3D shape. We could construct a 2D net out of paper or something like that and then cut that out and fold it up to make the shape. So this allows us to represent the sides, and that's an important thing that we need to do if we're going to do our calculations correctly, because we've really just got to count everything that that makes up our shape and make sure that we are including all those sides in our calculations. So with any prism, you're always going to have 2 ends. So we'll have 2 identical ends as well, because that's the nature of a prism. And then we're going to have a number of sides. And there are a few different ways that we can look at this that I'll show you as we move on. So let's do that example. So what have we got here? We've got, I'm going to start with my two ends. Now, my ends are, what have we got? They're triangles, and they've got a base of 4 and a height of 3. So I've got two ends multiplied by, now remember the formula for a triangle is a half of the base times the height, so that's going to be 3 times 4, and so I'm going to end up with the area of my two ends being 12, and we've got meters squared as our unit for this. Then I've got three sides. Now the sides are all different because one of them is 3 meters. Oops. Oh, come on, computer, what are you doing? 3 meters there. We've got 4 meters here, and we've got 5 meters here. So, and they are all 7 meters long. So I've got three sides then. Now, remembering that all your sides on a right prism are going to be rectangular, which makes your life nice and easy. These are all different, obviously, so I've got to do calculations for each one. Whereas if we had an isosceles triangle at the end of our triangular prism, then all our sides would be the same. In any case, pretty straightforward still. So I've got 3 times 7 gives me 21 meters squared. I've got 3 times, not 3, sorry, I've got, get rid of that, I've got 4 by 7, gives me 28 meters squared, and I've got 5 by 7, which gives me 35 meters squared. And then my total surface area, I've just got to sum all these values. And I get 96 square meters as my total surface area of this triangular prism. There is another way to think about finding the total surface area of a prism, and how you use this one is really up to you, or it might depend a little bit on the nature of the question, where perhaps you might be given some additional information about the ends of the shape of the prism, and that will maybe make this approach a little bit more of a sensible one to choose. But they're really all doing the same thing. Now, what I'd just like to highlight is thinking about the net formed from our prism, and then we're going to ignore the ends, because you always need to find the area of the ends if it isn't given to you in the question. So it doesn't matter what you're doing, you always need to do this. But what I'm suggesting here is that there's another way that we can think about the area of the sides. So we get rid of our ends there, and so what we're left with is a rectangular shape. Now, it doesn't matter what sort of shape your ends had, the sides will always form a rectangle, and you'll always have the height of that rectangle being the same as whatever, you know, the length or height of your rectangular prism was. So what we can think about here is that the lengths of the sides will then add up to give you the total length of this new rectangle that we're looking at. So in this case, we've got 3 plus 4 is 7, plus 5 is 3 plus 4 is 7 plus 5 is 12 meters. Sorry, that wasn't my finest work. So in this case, the area of the sides is just going to be 7 times 12, which is 84 meters squared. And then we would just have to add the area of our ends on and get the total surface area of our prism. Just be conscious that when you're doing these sorts of questions, you've got to be a little bit careful with what they're asking you, because sometimes you'll get asked questions which might be about, you know, say painting the outside of a shape or something like that, where you might not paint the bottom of the shape if the shape is, you know, forming a garden shed or something like that. So just be thoughtful about what the questions are asking you, which is obviously a pretty standard thing you need to do when you're answering questions anyway. Okay, so in summary, When you've recognized that you're dealing with a right prism, in order to find the total surface area of that prism, we can either just calculate the areas of all the sides and add them up. Now remember, you'll always have two identical ends and then however many additional sides we've got depending on what the shape of the end was. Or the other way you can do it is to sum the two ends and then multiply the perimeter of the end by the length of the prism, and that is another way of calculating the surface area of the sides. And we add those to the ends and we've got our total surface area of the whole 3D shape. What to do now? Attempt the exercises. As I've said previously, check your answers regularly, get in touch with your classmates to help each other out, and obviously contact your teachers if you're stuck. Thanks.